All right. We're getting back to basics a little bit today, guys. We're getting back to basics a little bit. Let me make sure I got everything set up like I want. There we go. All right. I think I got everything kind of organized like I want. Throw a water bottle here. Hey, never fear. Thanks for the subscription there. Look, I can put that over here. All right. Yeah, thanks for that. Yep, Scott is here. We are going to talk, we're going to go back to basics. We're going to do Linux for systems administration. We're going to talk about getting Linux and getting into the enterprise. Up here on the top right, you're seeing a whole bunch of jobs that people had picked up when we first did the Linux systems admin course. I asked people, hey, go find a job that's interesting to you. And then we kind of worked through, and throughout the course, we kind of aligned to these different things that companies want. And what I did was I kept a bunch of them, and we've been working through them on stream here a little bit. So I'm going to work through them a little bit while we kind of talk, and then we're going to do some Linux while we're kind of doing that. So let's get into that here. I'm adding some numbers here as we go. And then we'll talk about like what we can do. So the first one is analyze system logs and identifying potential issues with computer systems. All right. Logging, right? How do we look at logs on a system? Well, obviously we got to know where logs are. So var log. And in there's a bunch of logs. And in Linux style system, or in Linux and Red Hat style systems, we really care about two logs that come with the system. The one is the messages log. That's like all the sys logging goes in there. And then the other one is secure. So if you're in a Red Hat style system, the types of logs you're probably going to look at 95.5% of the time would be messages and secure. Okay? So let's look at this real quick. So Xshunya, that should still be running, the ask, but I don't know if it's going to... It should talk. I don't have it turned off or anything. That should talk even though I don't have the other screen up. So, what is last log for? Yeah, we can go look at it. Right? Should show connections. I'm used to using wtemp for that. So wtemp is a log that you'll run into a lot as you use tools. But wtemp's another one of those, just like this one, where you're not really designed to look at it in the raw format. You're really supposed to look at it through the tool, something like last, right? So last is referencing wtemp. And if you want to know more about that, read the man pages for that, right? That tool. But what I want to show you guys is, let's say, work with logs and identify potential issues in computer systems. Well, we could sit here like this and tail out var log messages from anywhere in the system, and we could do that, and we could even sit here like this and do a tail-f on var log messages and look for new errors coming up. But I think most of you would very quickly realize that, like, well, I only have so much space for this one, and then I only have so much space for another one, and I have a few thousand servers I have to keep track of. So this isn't really a tenable solution. Now, when I have a problem on one system, I will absolutely do something like this, right? Like this is pretty much the standard for, let's say some user was having problems logging in, and we were even having this the other day on stream, or not on stream, but we were working on getting people access into our Linux environment, and we'll do something like tail var log secure, and then we'll tell the user, okay, go ahead and try to get into that box, and the user will try to connect to that box, and over here we'll get what happened with that user, right? So over here, I see that root has used a key. What if I come back over here and I bounce out, and I see that user has disconnected, so root's disconnected. That's good to maybe know. But let's say then that maybe somebody's trying to log in as like fake user at Rocky9, and now they've got a password, and they try the password a few times and fail. Well, over here, I'll see that there's an invalid user for fake user. Now, this is fine. Again, if somebody's trying to get into your system and they're on a call, or you're like doing some kind of work session or something, and people are trying to get into your system, Sure, like that's obviously, this tells me some things. The user you're trying to get in on, my system doesn't know about. So now we've got to figure out where you got that username from. So you've got a username I've validated through whatever methods I need to. Maybe somebody handed you off to me, like some manager talked to my manager and handed you off to me, and that's what got me out of doing whatever engineering or systems work I was doing. And now I'm trying to help you, and you're trying to come in, but it's a user that's invalid. Well, full stop. We don't have to troubleshoot anything else. We know what the problem is. The user doesn't exist. So now, this may be a business thing. This may be a technical thing. It may be that somebody on the business side, somebody over in the identity and access management team, never made the user. What I know for certain from the log is that the Unix system, the Linux system that we're on, does not know about it. Does that make sense? Alternatively, they could have known about it and they could have pushed a button somewhere, and that may not have come all the way through and built on this node. Maybe this is a newer set of servers, or it's in a different IP range than wherever that other tool works, or maybe who knows why, right? There's all these other things that can happen, but what we know is that if we don't manage any of that stuff, this is no longer a Linux problem. Does that kind of make sense? Now, I'm not telling you to just tell a user to go kick rocks and go get his stuff working. No. We could probably go track that down a little bit and help them out. But a major thing to understand here is that this is what the system's seeing, and this is what the logs are showing. But this up here is more talking about identifying potential issues with the system. So what might we see in a system that's having problems, right? If I was over here and I was just on a Linux box, I may expect to find error. I might do something like this, -I, capital E, and then say error, maybe kernel, or I don't know. Let's say maybe error, kernel, or warning from everything. We'll just search for that for everything. And then maybe I can see that on January 16th, we had a whole bunch of kernel issues on the system. Maybe that's even when the system reboot. Oh no, Rocky was having some kind of out of memory kill error. So maybe we even find out when we're looking at this system that the system's only been up 5 days because it got rebooted. Yeah, that looks about right. 5 days ago. And we could figure out like what was happening with systems. Sometimes we're looking forensically at things that have already happened. We know something happened to the server last night, and now we're trying to figure out what happened. Well, I can see that this system went out of memory and started using the out of memory killer. There were some massive problems, some kernel issues, and then I can tell that the system rebooted, right? So that might be something of value to look at, right? But normally in here, what we would really want to do is we would make sure that maybe our systems are, so maybe we do a system CTL status promtail. Maybe that's a tool we use. I see promtails running, and then I CD to maybe over to opt and then promtail, where we put our agents typically on a system. And then we go look at the promtail local config file, and we see that we send off messages and secure off of to this Loki system here. Now that's cool. So now we have some third-party tool. I can pull up that tool right here, and I can go look on this system. Was this one a copy of my other one? Let me see. I think nope, maybe I was editing my original one. Well, that's fine. Let's go back here, and then we'll say we want to look at secure for maybe Rocky 9. And now we can see all the secure messages for Rocky 9 in the last 24 hours. By the way, those were the ones we were just looking at. And also, maybe we want to switch over to messages here, and we can go look at, yeah, we can do Rocky 9 still. And I can see all of those messages of what's been happening in the system. I can look for errors. By the way, anything within this logql tool, so logql is the tool that we can search. We can go learn about that tool, and we can go learn how to do searches and alerts and all that kind of stuff on there as well. All right, so I'm putting this out for you guys that need it on the Twitch and the YouTube side. Oh, hey, sorry, I'm not even paying attention to what's going on. Tomorrow, you said, looks like a job you're applying for. Well, good. We are not working too hard, but we are back to basics today. We're back to one of the things that we, I think, do well, which is look at how the skills for a job kind of map to the skills that we actually have inside of a Linux system. So analyzing logs, make sure, or maybe we can say look for errors in logs, and then that's a, grep something. We could say make sure our tool is sending logs off the server, right? We wanna have our servers out there aggregating logs to places that are off the servers. I've told you guys this often, but this is 100% true. You do not want to have to bring a server back up to be able to get to its logs. Its logs need to be launched off, or as you youngins say, yeeted off the server in real time. I'm just fucking kidding. I don't care. What type of project would you like to see if you want to show you can do the job? Tomorrow, I'm a big fan of... hey, Tomo, how's it going? I'm a big fan... so there's Tomo and then Tomorrow. Tomo's my brother. So Tomorrow, the question was, what kind of, things would I want to know that somebody could do a job like this? Well, look, they want all the normal things. Monitoring... They want you to be able to install stuff and troubleshoot stuff and patch stuff, secure stuff. These are all the things that we're always hitting on and building. So let me pull this up real quick. Hold on. I don't know why for just today my Discord decided to be twice as big when I brought it over here in a screen of the same relative resolution. Let's go over here. We have a whole bunch of project stuff. Obviously, we have the Prolog projects. And I think if you go in here and then you just scroll all the way up to the top, right? Just scroll all the way up. You'll get the original projects that we did in here. If we can get all the way back. And one of the projects that I'm a big fan of, my niece told me, so 2008, that's funny. And this was our very first project on this page, was this monitoring deep dive project and monitoring. And what we did in there was we built out monitoring. And I had you guys go through labs where you could do all the monitoring. And honestly, I think that's one of the best things you can do. I may be a little bit maybe biased here because I think that that's good. But you can show that you understand monitoring. You can show that you can connect to monitoring and do things with it. Oh, you did it? Okay, yeah. Well, it doesn't necessarily have to be on a resume, but it should be something maybe that you can show somebody. You just talk about it. Tomorrow, you talk about, that, because here's the thing, right? At the end of the day, there's two things people want to know in an interview. There's only two things ever that they want to know. Can you do the job? Will you do the job? Hey, Producer Wolf, how's it going? Yeah, I'm hoping stream goes good. I'm just kind of hanging out. I'm using OBS directly. I don't use the Streamlabs stuff anymore. And I think I have it all set up right because it tends to go to the two places I want it to. And, I think you guys can hear me, so that's good. Yeah, tomorrow also, people have been doing kind of resume reviews for people and stuff as well, so there's that. And I've talked to the guys about, we're going to try to do a little mock interview session with me and some of the guys that run interviews for people and let you guys kind of get the experience of, what's going to happen in an interview. I show you guys behind the scenes of interview stuff that I do all the time. As a technical interviewer, because I tell you guys, nobody's ever brought me in to find out if the personality fits. Nobody, not once ever. I'm always the guy. You'd be down for that? Okay, yeah. Leith, I don't always link you guys, but yeah, I can remember you. Interview your brother. I'll get the popcorn. Well, Boris, I'd like to interview you guys. I'd like you guys that want to go get the jobs to hang around and sit down in the hot seat for a little bit and see not the pressure of it, but just the kind of questions that we're looking for, the kind of things that I'm going to ask people for. So make sure our tool is sending off server. Let me see. So you got to know, you need to know how to grep things. You need to understand your grep tool. This tool is relatively simple, but it's grep and then it's flags, right? Capital E will allow you to search for something else, and then more stuff, right? You can put as many things as you want in there, and that's the extended. I used to use egrep, but somebody told me it was deprecated a while back, so I stopped using it. Lord Processor, sir, is there a way you can provide the commands used for troubleshooting on the notes? Yeah, so I'll add them, Lord Processor, and then I typically take these notes, and in our Discord, I will a lot of times throw the notes up in like our memes and jokes. Like I'll put it up in the meeting notes. So I'll put stuff up in here. So actually, you'll find other job stuff that I've done in here. Like I'm pretty far down on this page. I put the different notes and stuff up in the thing. So yeah. Yeah, Boris, I'll tell you, I never became an expert with set and awk. I can do enough set and awk to get through the day, and then I just look up stuff that I need. So like I feel like I'm good enough for set and awk to do my normal daily things and fix stuff. But I really just, if I have any like crazy stuff, I'll just go and look it up. Yeah, awk-f and then dash cap f with our actual field delimiter that we want is one of the main ones, and the print against the different columns. Yeah, I'm a simple guy, guys. I do simple things well, and then that kind of has translated to being, people think I'm good at what I do, and I'm like, I just do simple things. Like I don't do super complex things at the command line. I just do simple things well, I think, and I know how to reference stuff. Like I can look up an awk or a sed command if I need. So that's kind of another thing. But like, let's say you're on the job day one, they're not going to expect you to set this stuff up. But they might just, maybe even as you're dusting off, old documentation that's never been worked on, you find out that they're supposed to be running Promtail everywhere, and that's a thing that you can check. By the way, I tell you guys this is, we had somebody ask me a while ago, he's like, hey, Scott, it's my first day on Monday. This was over a weekend, probably 3 or 4 months ago. And somebody said, what do you think I should be doing like the first couple weeks that I'm in there? And I told him the same thing I'm going to tell you guys. I would read all the documentation I could, and I always build my own little map of the environment. I draw it out myself. By the way, that when I've done that, and I'm not saying this to be a Chad, this is just true, that has become the standard document for pretty much every company I've been at the last 15 years. And you say, really? And I'm like, I'm not even that good of an artist, guys. It's just I look at how I connect to the system and then how it all flows through, and it becomes the standardized doc. And then here's the thing. The other thing you do as you're drawing that out for yourself, you're figuring out all this stuff about the system. I start to document what is wrong with my onboarding process. Like what do I not need to, like, what do I not have? What did somebody say? Oops, we didn't add you to that meeting. And I document all of it. And then the next time somebody gets brought on, and this happened to me quite a few times, they're like, oh yeah, Scott just went through that. Could you give it? And I just drop a list in like Teams or whatever. And they're like, oh, that's a really good list. We're going to use that now. And I'm like, well, shit, this is all the things that I tripped over in the dark. And I just like put a little neon thing there so that I wouldn't trip over them ever again. And it becomes the standard. The other thing I would do, so these are 3 things. One is draw out what's going on, document your onboarding process, and then find documentation as you're reading through stuff that's not good and start updating it. Just updating it to the most recent stuff. And I'll tell you what, in like 2 weeks, 3 weeks, people are going to think you're a freaking rock star. And you're not even doing anything hard. You're literally just reading stuff and like fixing simple stuff. Guys, you don't, like, I jokingly say this, but it's kind of true. And I think if my brother's still around, he'll agree with me. Like, to beat 95% of people, all you have to do is show up to work on time and not complain. That's all it takes to beat like 95% of people. I mean, like, now, okay, look, that doesn't help you get the job. I get it. But I'm saying, like, once you're in the job, just do the freaking job. All right. So anyways, those are things that I kind of think are important. Now, applying system updates, patches, and configuration changes. This starts to get into, hopefully there's a process, but if there's not a process and you do have to build it, you're going to have to, so system updates, right? So let's start with system updates. That's super easy, right? That's simply either a yum.y update or take out the y, and then the maybe DNF update. And that's pretty easy to do, to just update a system, right? But what do you actually need to know a lot of the times with system updates? Well, you need to know where are the internal repos? Please tell me you're not using external ones. Like, please don't be running external repos. Like, if you get into an organization and they're running external repos, like just downloading shit off the internet, like it's the wild, wild west, I would tell you to, like, maybe even if you're a junior admin, go, guys, we really should build something internally so that we can filter what comes into our organization. Like, that's not even like I don't want to say that's like a non-negotiable, like you should just quit. I'm just telling you, like, that is something that will absolutely haunt your nightmares. Like, it will haunt you waking and sleeping hours if you are just patching stuff directly off the, because now you have no control. You patch down here in dev, and 2 weeks later you go to patch and prod, and it's a totally different set of downloads. You have no control over things. And I tell you guys, like, big part of good engineering is like grabbing control and holding on and being in charge of things, right? Anyway, so all right, so don't use external ones. So, but you can't just be updating the system willy-nilly. You have to have on your system updates some type of schedule, right? And then everything needs to be done on that schedule. Where are your internal repos? How are your exclusions configured? And your exclusions are the things that you don't want to have happen, right? I mean, what does an exclusion mean? It means that I say, Colchis and Never Fear and Tomorrow, you guys can all come hang out with me. And then Robodom's sitting there like, oh, but you didn't say me. And I'm like, yeah, I excluded you, right? Well, that's a jerk move here. But there are things that you're going to exclude. Like, we maybe don't always patch kernels. Well, it makes sense that you don't patch kernels if you're not going to reboot, right? Like, if you're not rebooting this. Yeah, Robodom. Action, yeah, I could do that. I'll map it for you guys this Saturday, if that's okay. I'll put that on the schedule for our meeting. I'll say, let's make an event here. Create event. We'll make it just a normal voice channel because I don't think there will be that many people, and we'll call it the Prolog meetup, because we normally do a meetup on Saturdays. I had canceled it because we hadn't. I had canceled the official meeting one. It'll be 3 p.m. my time, does not repeat, and we'll say general hanging out and talking about Linux. Scott to map out his home lab environment for everyone's amusement. All right, good. Yeah, because then I can get my home lab kind of set up. We can say het, because some people don't know. Right. All right. We'll do that. There's a meetup right there. So if anybody wants that, you guys can... Oh, it's hidden because we're in like a streamer mode or whatever. But I'll go drop it in general and say join this Saturday. We'll do some Linux. There you go. Oh. Well, I did use the copy button. I swear I used the copy button. Share. Copy. Says it's copied. That's embarrassing. Alright, whatever. Someone link for me. There we go. Alright, you guys can link. Somebody can link that for me. Alright. But we're over here doing Linux as we kind of go. Patches. Patches. They can come from the repos. Can also be custom or internal. We can say custom or custom software. So sometimes we have to help deploy that. And can also be from source. So sometimes it's source, and now you have to control that, and then you have to go figure out, you know, Am I doing this as an Ansible playbook? I would always advise, if it's me, that you have a local repository for controlling that, right? Like a staging area. Even if you just bring in some source code and put it up in your Bitbucket or GitHub, whatever internal GitLab. I don't think GitLab's is popular anymore, but like Bitbucket is a paid-for version of, Bitbucket's a paid-for version of like internal GitHub. Whatever your repo is, I'm saying, you can use that software. And then your patches, I would say, build them in dev for your internal customers, which tends to be for us as engineers and Linux guys, that tends to be our devs, like our software devs, like our guys who write code. We support them by being able to bring their software packages in a manageable way. So I would build them in your dev, and then I would automate with Ansible and build into your pipeline, right? So your pipeline for building servers should be automated. So you can build anything you want by hand. Like, you guys will see me build stuff by hand all the time. But then when you're ready to kind of like put on the big boy pants and get out of the dev environment, I say put on the big boy pants, but basically what I mean is you want to suck it up and actually do some real work. You take all your notes and you turn it into a playbook, and that becomes a repeatable process that you never have to touch again, right? And it kind of seems a little silly, but that's the way that I like to put it, because it makes sense to me, right? Like, we can go play around and do dev stuff all day, but when we're ready to slide it up into the pipeline, it has to become like a work product, and my work product tends to be Ansible. That tends to be the way I like to do things. So, all right. What's the last one? Oh, configuration changes. So, configuration changes are surprisingly a business problem. And the reason I say they're a business problem is this. You can put in a ticket to the admin team, like the Linux admins, and we all have root, right? Like we're root in our company. I can go do whatever the hell I want. Like, I'm just, it's wild, wild west here. Shoot up, do whatever, fix the problem, put my feet back up my desk, and go back to not doing anything because I'm a Linux admin. But that's not repeatable. That's not good. That's not, for lack of a better term, that's like kind of bad administration. It's not anywhere near engineering, right? Configuration changes it's a business problem. We need to follow procedures. Do you guys know this, that engineers tend to be a little above average probably on like smarts but for one thing for sure about engineers, for being people that tend to be able to follow through a rule set, they hate following rules. Like, a lot of engineers I know are just like, they'd be anarchists if they could, right? Where I'm going with that is they don't want to listen to other people put guide rails and little guardrails on them so that they don't crash the ships. They just want to run around like it's the wild, wild west and shoot stuff. So we need to follow procedures. Those procedures tend to be, in engineering change boards, ECB or CABs, and those are engineering change boards or change advisory boards, right? So these are engineering or change boards, and then you have to follow through those processes. And I have notes and notes on that kind of stuff. Someone clipped the shooting sound. Yeah. Just being up like in the wild, wild west. It's probably less common now in cartoons than it was when I was a kid. But when I was a kid, Yosemite Sam would come out and just be shooting everywhere. He'd be shooting down through his... that guy was always shooting something. But yeah, so... you're looking at this and you see this simple thing like system updates, patches, and configuration changes. But honestly, if you got to talking about this with somebody in an interview, you could probably keep them talking about these three topics for the whole hour you're there, So, you think about this stuff and you say, well, how do I get better at this stuff? Well, you probably have to have maintained some of that. You probably have to have an environment at home where you're not just running a few servers, but you're actually putting them through the paces of updating them and making sure that they're set up. I have not kept my home environment updated nearly as much as I should, but If we want to make like a Linux system admin, you know, like a little example and patch all the systems and stuff, we can do that. I think a lot of my systems we're starting to see are completely out of support. Like I tried to patch Hostbox the other day and that thing just did not have what it took. So now I have to go and move everything off of Hostbox and probably build him over again, as well as P01, Jump01, which are my main two servers in my home lab, right? All right, so look, these are some things that you could kind of practice and learn about and talk to. One thing that I didn't show you guys yet because we're still just down here, if we do an ls-l on Etsy dnf.conf, you'll see that. If you do it at etsyyum.conf, you'll see that it points over to dnf.conf. So if you cat etsyyum.conf in your environment, you'll see if there's anything in here that is excluded. We don't have any exclusions in this lab environment, so that's good. But we could put exclude in there and then exclude kernel patching and those kind of things. That would just look like this. Right, so exclude anything kernel. And I'll prove this to you real quick, right? Let's do a DNF install, DNF update. And we'll see, watch this real quick. We'll see, 192 packages, 5 to install. And you will not see anything up here. Look, it starts with Network Manager, comes down. You don't see any kernel in here. No kernel in there. But by the way, kernel would be at the top because it would be installed. These are just things that are being upgraded. All right, so we don't see any. Let's go back in there and just comment out this line. And then we will do a DNF update again, right? So the system will go, it'll check against all the things. Now it's 192, but there's 8 to install. And if we look at, here's some dependencies, and if we go to the top, there it is. There's the kernel core and the kernel module. So we want to go to a newer version of the kernel than we're currently on, right? And I showed this to you guys the other day on stream, or actually in one of our patching labs. There we go. Robodom got it. But I wanted to show you guys here. Then I went up and somebody said, well, can you show us that little portion you did? And I said, yeah, we could do that in Ansible. And it looked just like this. It was basically, you could just back up your original yum.conf. You could change your regular exclude line to a commented out exclude, meaning get rid of all those excludes and patch everything. Then you could patch everything, and then you could move the original file back. And this is a process that I actually use professionally right here. It's part of my professional project or process. I have some other things that I do, but that's a big part of it, right? So yeah, Robodom's better than Claude AI. Nice. Yeah, fair enough. All right. By the way, guys, I'm using OBS, so this is my first time with my green screen on this, and it looks like it's pretty good. Looks like it's filtering the light out and the color pretty good. So, yeah, I think it looks better than the one that I was paying for. Like OBS is free, and it looks like it's doing pretty good. So, all right. Anyways, where were we at? We're doing Linux stuff, right? And we're over here. And what's our next one? Our next one is, can we install and configure new hardware? So hardware, software. And okay, so let's say smoke. What the hell is smoke? So hardware. So there's going to be a certain amount of protection of the system here, right? I have no idea what just happened there. Hey, thanks for the follow. And I don't know what's going on with the screen there. I don't know if we've hit some kind of something, but like some kind of default or something. But I guess it looks fine. You can ask me a Linux question if you want, sure. But here, protection of the system. So, can you install things without breaking everything? That's important, right? And then another one about hardware is, can you verify and ensure it is working with the system, drivers, kernel modules? Can you do all of those things? Everyone should be use man page. Yeah, well, you got to use man pages, I think, a fair amount. But yeah, Escaminha, you can definitely ask whatever you want, and I will try to answer it as best I can. But hardware, what do we? So you got to understand the types of systems you're on. I'm on virtual machines here, so I can't add physical hardware to these. But if I was trying to add physical hardware, maybe to some server that was out there, what do I know about it? Well, I got to take downtime on that server most likely, unless it's some kind of hot swappable disk, or maybe some fans in certain devices, maybe. You're probably going to be taking the server completely down to slide it out of the rack, and even then to get at most of your components, you're going to have to do that. But what do you check for when the system comes back up that you properly installed it? Well, we've talked about dmessage. Dmessage is one of your buddies because it shows you everything that comes up. And when I reboot a server and have put something into it, I'll do dmessage grep for error. Make sure there's no glaring errors. Maybe if I know that it's some type of PCI, I'll check for it there. And I will also do LSPCI to see if there's any hardware components added to the system that I needed. Now, before I go taking a server down, I do an LSPCI always, and you can just throw it into like temp, PCI bus dot date plus %f, something like that. You don't even need the dot text on it if you don't want. And then if you just cat your temp PCI, you'll just see your files there. And then anything you change, you could then go compare against that later, right? It's like one of these things where we've got all these tools to take notes, but not everybody always uses them. You've been advised to consider Debian, Ubuntu Server, Proxmox, and TrueNAS, but I'm not very familiar with servers or Linux, so I'm a bit unsure about which direction to go. What are you doing? Are you building like a home lab? Are you like... So let me just ask this first. For fun or for like trying to get into the industry and business? The reason I make that differentiation is this. For home lab and fun, do whatever you want. If you... Oh, hold on. There's two. Hold on. It scrolled up. From your experience, what would be best? Oh, it is a home lab. Okay, yeah. Server tests and apps I'm creating for computer science degree. I'm still at the beginning, but I set up something where I can use Cloudflare tunnels and Grok or other suitable options. Oh, yeah. No, they'll Java, Python, Socket, GDP. Yeah, I think Ubuntu's fantastic for that. By the way, Ubuntu has been, for the last almost 5 years, has been acceptable for government projects. So it used to be when I would be building stuff for the government, it was always Red Hat. All Red Hat because they were supported. Now it's a lot more rocky, and Ubuntu-style systems have been moving in there. So yeah, no, that's absolutely perfect for your home lab, because really you just need to be able to carve up your systems and make them talk to each other. So I think everything you have there is fine. Proxmox is great. I use a tool called XCPNG. I like it because it looks nice and it's easy to run. I've got 3 physical servers. I got a whole bunch of virtual machines doing a whole bunch of different things in my environment, right? I can look at them. I can control them. I think Proxmox is more supported, and you get a lot more of like your Terraform and your OpenTofu and those type of tools interacting. The providers, what are called the providers that you use when you run those applications, are easier. XCPNG doesn't really have any of them because it's an unsupported fork of Zen. Well, it's a less supported fork. TrueNAS might be a bit overkill. I mean, unless you really just have a lot of storage and stuff. Yeah, Ubuntu's fine. It's fine. It works well. I'll be starting on a very regular machine and use like Dockers to implement my code. So I'm not sure if VM managers are not too much for me right now. Yeah, so I know a lot of the guys in our Discord like running Proxmox. I have no problem with it. I tell people, do whatever gets you your system set up the way that you want it to be. It sounds like for you, you're gonna want a few things if you're a computer science student, and I know this because I've been teaching networking and security and Linux and computer science for 16 years at the college level, so I can definitively say what I'm about to say to you. You want to be able to spin up systems quickly, do your little tests on them, and probably tear them down. So you're gonna want some kind of whatever you use. If you don't want to go something as big as Proxmox, if you want to run something like even just a Oracle VirtualBox or something on your local machine, That is actually perfectly acceptable to just spin up boxes quickly with. Um, I haven't seen Nutanix yet, but I've heard about it a little bit tomorrow. But if you've been looking, you've probably seen more than me. I think Oracle VirtualBox is fine for a lot of that stuff. But really, whatever your workflow is for home lab stuff for computer science students, I would tell you for sure be able to spin stuff up quickly and destroy it quickly. Because what you don't want is to be stuck. Like I don't use XC or I don't use Oracle VirtualBox very much. But I'm gonna pull it up for a second to show you guys something. What you don't want to be doing is this. You don't want to be like, all right, well, it's time to do some computer sciencey stuff. Let me go spend 4 hours building a frickin' Oracle, an Ubuntu box or something. Well, that's stupid, right? Like that. Why waste your time in this? You want to be getting good at what you're good at. So I always tell people this about systems work. What the hell's going on here? I don't even like opening this. See, that's why I don't open shit like that on my home machine. I always go out and do my virtual machines for. You will have a dedicated computer. Yeah, don't see. That's exactly what you just said. Is my pet peeve. Like I've been an engineer long enough. I don't like doing anything on this machine. In fact, people come in here all the time and they're like, "Why is he using Windows?" Who gives a fuck? I'm over here with a whole virtualized environment of all of my actual systems that are all Linux, right? These are all my boxes that I care about. Who cares how you get there? But again, to that point, I don't want stuff on my local machine slowing it down. This thing's got it's like an i7. It's like Dell G15. It's got 64 gigs of RAM. I don't want a single gig of that RAM being used on virtual machines in my home environment. I want it all being used to play a game called Brotato, right? I'm just kidding. But anyway, so installing hardware is not super difficult, but it is time consuming. It also means that you have to be willing to go. If they're asking you for hardware, you have to be able to physically get to a data center, typically, right? So know that. I know a bunch of people got shocks today and yesterday that they're going to have to start going into the office, like in the federal government. Well, I mean, if you were working on hardware, you had to go in the data center, anyways. So there was no real getting away from that. All right, software. Is everything that you're installing supportable? If the answer is no, can't use in the government for sure. Can't use it in most enterprises. Excuse me. What do I mean by that? Is there somebody that you can send us a ticket to, that you can call? They jokingly call it somebody's neck to wring. You can't be the last person that's ever gonna support this thing. That's not how the enterprise. That is not part of any company. I guarantee you right now, no company on planet Earth has that as part of their risk management profile. Oh yeah, Bob over there in Linux, that guy. He's the last guy when we have a kernel problem on our Rocky 9. He's going to be the guy that supports it. No, he's not. You need to have somebody that you can call. So, like, the reason Rocky can be used in government environments is because CIQ is a company. It's called CIQ, and they have support contracts, and you can pay them support contracts. Otherwise, you have to use something like Red Hat, where you can pay them, or SUSE, which is SLES, which is SUSE Linux Enterprise Server. You have to be able to SLES. Yeah. All right. Thanks so much for your help. Yeah. Escaminha, we have a lot of people down in the Discord. I don't know if you play with Discord, but you're welcome to hang out down there. And there's a lot of people that can help you out with the home lab for sure. Some of those guys love talking home lab. I don't mind talking home lab. I'm just telling you it is. What is the best way to run Linux on Windows? I wouldn't run Linux on Windows. I would run it on a separate device if I could. I guess if you had to, Oracle VirtualBox or WSL. I know people who use WSL. At the end of the day, it's like how much do you want to compartmentalize the device you're on into other things, and I want it to be somewhere around 0. I want to use my server. I want to use my home machine for home machine stuff. Like I want to be able to talk to you guys and play Netflix on another screen without any problems. No, I'm just kidding. I don't watch Netflix while I'm on here. Yeah, WSL. Yeah. So you guys are welcome to hang out there. If anybody's here that hasn't ever met me or heard me talk about it, the reason I get on streaming is not because it's going to make me wildly popular or rich one day. That's not going to happen. But what is going to happen is we've got about 3,500 people down in the Discord where it's professional Linux users group. It's people who are either hobbyists that want to become professionals or professionals that want to help you take this from like a hobby into something that you can do professionally. And one of the cool things about being a Linux group is, man, we got people down there that are doing Linux for fun. They never want to. They never want to make money at it. I play with Linux all day for fun, even when I'm not getting paid for it. But there's also people who want to go be programmers, and we've got quite a few guys in there that are software engineers, back end, front end, all that kind of stuff. They know all that stuff way better than me. We've got DevOps guys and SRE guys, and the point is, like, Linux is kind of like a glue for like all of these other things that are out there. Yeah, I'm a national treasure in my own mind for sure. What I tell you guys is, I've actually told Fisherman, I'm like, I'm just gonna hand this all off to you one day, and then I'm just gonna disappear, and you guys are never gonna hear me from day. So Fisherman runs the bot, and he runs some of the other stuff in there, but he's the guy who's gonna be there. Yeah, X Shunya, I will definitely, man, we're gonna be doing the digits thing from NVIDIA. If you guys haven't heard of that, it's like a little kind of desktop form factor machine that's coming out that's going to be pretty killer on the GPU side of things, and it's only going to be about $3,000. So it's within the budget. I checked with the wife. I'm allowed to use it. I'm allowed to get it for the ProLug group. So the ProLug Urban Legend. That's funny. All right, so let's go back to this. We want to put We want to put some type of, I'm on the wrong screen here. We want to put some type of software on our system, right? So how can we get software on our system? Well, we can add new stuff, DNF install calce. Let's say calce is not there, and it'll try to install it. Or it'll tell me it's already there. I hate calce. 3K to digits, 2K to 5090. Interesting. If there's a little bit of an upgrade on it, I may look for doing a little bit. All right. So over here, we can install software just like this. We can download and run software. So maybe if we were doing something like, let me see if I have it. Do I have it on here? No, that was a different one. Maybe if we were going to try to install, let's say like Prometheus, right? Let's say I wanted to put Prometheus on this box. I don't really want to, but let's pretend like we wanted to. Let's look for the install of Prometheus here, and it's pretty straightforward if you've never done it. But let's say that we wanted to. We're not going to use Docker. We're going to actually build it on the machine. Where's that here? Choose pre-compiled binaries here. So we need to get Prometheus for Linux and for AMD 64. So it's got to be a 464-bit type Linux, right? And it says here that we could download it, but I actually want to copy the link address. And then maybe I might do something like wget that guy -o, and then I don't even know. Let's make sure we're in the right directory. We'll just put it here, and then oh, people are putting all kinds of stuff on here. I don't even know what's going on here. I have no idea what's going on here. It looks like people have been putting. All right, well, that's cool. People have been putting stuff on here. So, because if you guys know, in our lab, this is a shared storage, right? Okay, so hold on. So what I want to show you guys is, let's say I wanted to download this. Actually, you know what? We might put it back in root, and the reason is because then it's on the local box. Anyways, let's wget that, and then capital O, and then let's just call it the name of the file here, right? We'll just call it the name of the file. That's where it's going to go. And now we're going to download it. It's going to take a little bit of time because it's quite a bit. And then now, so we're going to have this tar, right? And we're probably going to have some kind of install instructions, right? We can go look at what the install instructions are They also have it already built into Docker images if we just want to do like a Docker run. I like to run stuff like if it's like dev and needs to stand up quick, I'll run it in Docker. But when I'm ready to productionalize something and make it like a real part of my system, I tend to go build it and run the full. And that's probably just because I've been a systems guy a long time and I'm used to processes and daemons running on servers and that kind of stuff. There's nothing wrong with running long running Docker processes. I have some that have been running in my home lab for a long time for like AWX and stuff. That's the upstream of Tower, right? Where my teeth? You're watching TikTok. That's funny. You know, you guys want to hear something funny? I mean, this might not surprise some of you as I'm 43, but I have never been on TikTok. I've run like my brothers have sent me stuff and I've seen TikTok videos that it's trying to get me to like download an app and stuff, but I've never had the app. So I'm not trying to say that to be cool or anything. I realize I'm old when I say that, but I'm just saying like I've never been on there. Like I've only like had people send me stuff and it I did that. I told you guys that so you would think I'm cool. No. I told you that so you guys would know I'm a grandpa, right? Actually, some of you guys know I've been a grandpa since I was 38. So, I mean, I am a grandpa. All right, this is gonna take a long time to download. Hopefully, we don't run out of space. It's only 108 megs, so it wouldn't be so long. Hold on, let me make sure you guys understand. The reason it's so long in my home lab is because of the architecture of where my lab is. I told you guys I'd draw this out on Friday, but I guess I could start drawing it out now. We'll draw it out on Saturday rather. This is going through a jump box, and that jump box is like hanging on like this to both sides of these two nets and passing this through. And that really shouldn't slow it down that much. I'm surprised this is going as slow as it is, but just know that this is a box that is way off to the side of any normal network. So I'm not surprised. I'm not so surprised that it's slower. But anyway, so we could do that. So software, is it supportable? Yes. For how long? What is the cadence? And then your GRC teams. So anything you put on a server needs to be tracked. You need to track it because you need to know if it's being updated. Typically, a GRC team, it's your governance, risk, compliance. Those teams are going to come in and they're going to want to know. And the reason is because you can't just be running around like the wild, wild west shooting your gun in the air. You've got to be within whatever. Yeah, well, where are my teeth? This box is sharing. Yeah, look, and then it just went. So whatever was happening is done. I don't know. Anyways, let's go look real quick. I want to show you guys this. PWD LS. So there's our. What the hell is that? Well, now I'm confused. Oh, God. You guys got to stop me. Yeah, you guys got to stop me sometimes. I don't know why I put it down here. I mean, I know why I did. I just don't know what the hell's wrong with me. Let's move Prometheus back to root real quick. So now df-h dot will tell us that we've got plenty of space. So let's tar-xzvf on Prometheus to take it all apart and pull that tar and zipped up package apart and put it into this directory here, right? Now, when you actually untar everything like this, you really could just drop it right in varlib. That's where they want you to put it. You still have a Prodigy floppy. All right. So, hold on. Where were we? CD to Prometheus. So now here it is extracted. We could look at it. If we didn't trust it, we could scan it with whatever our antivirus tool is. I don't have my antivirus tool on here, but I usually use like ClamAV, and then I can never focus if you guys are talking about me. You guys are making me. All right, all right, all right. But GRC, governance, risk, and compliance is a way that we can verify, and maybe 3.1.0 has some vulnerability in the future, and we need somebody to be tracking so that we know, hey, that vulnerability was introduced on January 21st of 2025. We need to have a plan to have it off the system. Now, look, if I were to ask you guys right now, how soon should you get that vulnerability off your system? I'm pretty sure all of you would rightly say we need to do it right now. But businesses can't do that. You can't just shift like that in a business when you might break something or change something. So typically, businesses will have risk management and then what we call a risk appetite, where it's like, well, okay, we can accept that risk of that software that has a CVS S score of, that vulnerability of under 7 for a month. But if it was like a 10, yes, we got to do it today. So that's pretty bad. So you have to kind of do all that. All right. So anyways, anything you put on the server needs to be tracked. So software, you just need to know it's not the wild, wild west. You're just not throwing anything out there. Everything you put on that server needs to be tracked, and you probably need to work on getting it into your pipeline for how things are built going forward. All right. So that's installing hardware and new software, right? You can download the software, you can run it, probably go read the new instructions. If it's something as simple, like they said, as just running a Docker image, that's cool, but just know that you need to probably download it and then have that Docker image, because what if that repo's down when you go to redeploy it? You don't want to be trusting outside repos. You want it to be trusted internally. All right. Next one. This is security stuff right here, right? Adding, removing, or updating user account information and resetting passwords. All right. So, how do we add users to the system? As an admin, what agents do you like to have on all your systems? Tomorrow, Mara, if I have my way, I will have 0 admins on a Linux box ever. Now, that being said, I never have my way. So, typically, I would say the agents. So the question was agents. I would say the agents that you are always going to probably have on there is something for your logs. And that can be like Promtail, or logs can also get sent with rsyslog. You can also have a Splunk forwarder on each of your devices if you want. Those are probably some of the most common ones. You probably want to have in any, for PCI reasons, so PCI compliance, you need an antivirus. And I say for that, ClamAV. And then a lot of people like Falcon Sensor, which is CrowdStrike. And you may end up having that, or may end up supporting that. Aside from those two, there is typically, instead of logs, you'll have metrics, or some people call this telemetry, which is just metrics at a distance, right? And telemetry just means metrics from afar. Then you may have very, very lightweight is Node Exporter. You may have Telegraph, which is also those are both very, very lightweight. And then another one that you might have, they used to be called the beats. There's like metric beat and file beat and all these other ones that you can do. I'm not telling you guys necessarily, sorry, these are not all ones that I would say that you're going to want to have. I'm just saying these are probably ones you're going to support out there. You're probably going to see them in your career. I for sure want Promtail and Node Exporter on pretty much all my stuff, because Promtail can send to Loki and Node Exporter can send to Node Exporter Node Exporter is collected from that, and then very quickly and very easily, I have this in my home lab, and everything works, right? This is my home lab environment for people that don't know. This is what my home lab this is what my monitoring in my home lab looks like right here. So this part's been drawn up for a long time. There's kind of the ingest, the storage, and the presentation layers of my home lab, right? most of you guys have been around when we've kind of worked through that or whatever. So, right. So ingest is any server has Telegraph, Promtail, and Node Exporter. They're sending off to InfluxDB, Loki, or Prometheus, and then presentation by Grafana. That's basically how I do it in the home lab here, right? Nothing super special, but this is something that I want. And by the way, these pictures are up in the Discord and the different projects. I want you guys to understand how these work. Is it being scraped or is it pushing? If it pushes, does it have the ability to buffer? And if it scrapes, does it have ability to scrape older data? And the answer that's no. If your Prometheus is off for 10 seconds, data coming out of Node Exporter is lost forever. You guys know that, right? These are you need to know how your tools collect so that you understand the limitation of the tool. What is the critical thing here? Prometheus must be up. If Prometheus is not up, all your nodes they're not giving any data. But if Prometheus is up and 3 of your nodes are down, the other nodes are still getting collected, but not those few. And then they're showing down in Prometheus, and now we have another data point that we can, show out of our monitoring or whatever. All right. What were we doing here? We're on a box, and we want to add, remove, or update user accounts, resetting passwords. Well, we can do, we can find things out about the user, so we can ID Scott. Scott is a user on the system. I think Scott 2 is as well. And we can see that the user's there. We can see where his home directory is. We can see a bunch of stuff by maybe just grepping Scott from Etsy Pass WD. And we see where Scott's home directory is. It's the 6th field of the file. There's home and home Scott 2. Now, it may surprise you to know, for people that have just used Linux kind of casually or messing around, it may surprise you to know that these can be all over the place. Your organization, if it doesn't have a policy for where people's home directories are, you may find them all over the place. Now, if your organization's been around and done Linux for a while, maybe you got some guys that have been there a while, this is probably going to be much more standardized, and this home directory is almost always going to be something off of the system. So in this case, /home is actually maintained in a NFS share off of this machine, right? Let's just mount, right? Home is an NFS v4 share off of Werewolf, because Werewolf controls all of that in my cluster. All right, sorry. Anyways, we can add or delete users with user add -h. Maybe I get some help on it. User del -h to get some help on it, and you can add or remove users. Now, one of the things I've asked you guys before, and I've made you guys test this a little bit, is when you delete a user, right, does it keep their home directory by default? And why is that a behavior that you need to understand if you're in a company and you're maybe adding or removing accounts? If you're removing a bunch of accounts from a bunch of developers and engineers that have been running in your company, and maybe you get rid of some contractors that were doing a bunch of work for you, do you always want to delete their home directories? Something to think about. Oh man, Master of my fate. I don't ever randomize user IDs. I allow them to be controlled typically by a third party like LDAP or AD. In fact, most of you guys, if any of you have worked with Active Directory in the last 10 years, you know that there's a little button as you're creating users in Active Directory where you can actually have it generate a UID for when it goes into LDAP. And then that UID will stay with that user that's coming out of like a trusted Active Directory down into our Linux environments, and they will always have that same user ID, typically up in like the 15,000 range or something. It's like up out of the way. You do want to do that if you can, because then when my team comes along and we hook our Linux up, and we don't want to be in the identity and access management like business. I don't want to be user adding and using user deling 10,000 engineers. That's absolute insanity. That would just be too crazy for me. I want the company process to hook up to us, and then our Linux systems can trust that. That tends to be what we do. So LDAP trust setup, and that used to be the old way. was Windbind and Samba. And the newer way tends to be SSSD, at least in the RHEL side of things. And also IDM is what it's called, Red Hat tool. That's also free, IDM. Or also Keycloak. That's an open source tool that'll do a lot of this for you as well. So yeah, guys, you'll find out, Master My Fate, you'll find out that, like, as a Linux engineer, I do not want to be involved with identity and access management. It's absolutely something I want to be completely outside of. Gizmo Gremlin, do I have a favorite LDAP Docker image? Never, I don't know. 5-shot. So here's the question: how do you support visibility of those files? You're talking like users? Well, if a user is set up properly in a system, you should always be able to ID username, even if it's coming in through like an Active Directory or something, and you should always be able to see them. Opinion on Sphinx or read the docs for user docs. I've never used Sphinx or read the docs. Most of my documentation nowadays is Markdown and Markdown, or I use MediaWiki still some too. Tends to be. I also use a tool. It's my company pays for a tool called what is it? It's by the Confluence. Any of you guys use Confluence? It's a good enough tool. My company uses it. No, I haven't ever used Sphinx or RTD. No, I bet. Well, so read the docs, I think, is the one that like a lot of the like Ansible and like open source tools use. So I actually do like read the docs. I haven't compared it. I don't do a lot of the comparison stuff on it. I guess I don't have enough experience with either of those. I think I do a lot with read the docs from reading them, and I seem to think that those look pretty good. Is this, hold on, is this a read the docs one? Like if we just went to Ansible, like inventory, this is a read the docs, isn't it? Isn't this? I think this is, because I think I've seen that name before. I think this is, yeah, this is read the docs. Yeah. I like this, but I couldn't compare it to Sphinx. I bet Sphinx is just as good. I just don't, I don't have a good comparison. I do like this, though. I think these guys do good, and I think that like they have some pretty good. Oh, they've cut out all those other ones, so now they just have the old devil ones. Okay, well, that's good. On a team, one of my engineers leaves. How could I see files in his home directory, or if his account is deactivated? Would you add his files to a central place? Sometimes not everything is shared or documented when offboarding. How do you handle those kids? Yeah, 5-shot. We always with engineers. Hold on. So this is because I've been on a lot of engineering teams over the last 20 years. And the rule is always this: you never delete their home directory as it sits. So let's say I go to home and here's Fisherman, and I absolutely am not going to lose Fisherman's stuff. We always have a policy of we will tar up his directory the day he leaves. So tar -czvf fisherman .tar.gz against his account, right? I will always tar that up right there, so now I have it. Typically, we'll even put a day on it. So move that to like that dot date plus %f, right? Like, oh, whoops, yeah, right. And then we'll have his date, and then typically I would just go in there as admin and read it. GZ is the standard I've always used. Master My Fate. I just use tar.gz. Yeah, bzip is kind of the older one, and gzip's kind of the more standard one now. So, delayed drain question: what is the difference between add user and user? I actually don't know. I've never used add user. I don't have one for either. Well, I don't know. Are they just, is one just symlink to the other? Yeah. I thought that was going to be the case. I thought that was going to be the case. Whoops, ls-l. Yeah, so that's funny. There is no such thing as add user. At least in a Rocky style box. So I guess hopefully that answers your question. I don't think you were trying to maybe stump me, but in my case, there is no such thing as add user, because add user is actually just a symlink to user add in that case. But I didn't know that. I didn't know that until literally right there. I've only ever used user add. I've never used add user. Well, it's the same binary, so I guess it can't be. That's funny. Or is it SBin? They're both SBin. They're both in SBin, but one's just a link to the other one. So on these are Rocky boxes, so they might be slightly different than what you get in Red Hat, but they shouldn't be too much different. So. Yeah, but 5-shot, I definitely just leave their home directories there, unless they were really big, and then I would move them off somewhere. I like that. All right, let's keep going. We're just messing around here. Well, not messing around. We're just going through. How do we reset path? So there's a few things we need to understand about users, right? So we can do chage-l on Scott, and we can see information about the Scott and the Scott2 user. And we can see if there's anything set against these users. We can see if they're locked. We can see if the password's expired or inactive. We can also set the password, so pass WD. We can set a password for a user. Now, this is one we don't do often because, again, I tell you guys, I don't like to be in the business of managing users' passwords. I want identity and access management to do that, and my systems will have a trust relationship with them, and SSSD or whatever tool I have to trust Active Directory will go and check the passwords for me. But that being said, if I do ever have to set a user's password and I know that it's correct, they're like, I can get into that one jump box, but I can't get into that jump box. There is always this option. Now, normally you don't show the shadow password, but again, this is just a bullshit one in my home lab. This is a made up one. You could, if that was, let's say this root one right here was your user, you could take that line of the working one and go drop it over the Etsy shadow line of their other account in the other one, and now their passwords are the same. Then what I would do typically is I do like a tail dash F on varlog secure, right? And I would watch as they tried to get in, as they tried to get in on the box. This isn't the real password because I'm typing test. And over here, I'd be like, dude, your password's failing. Like that's what's really happening on your system. You're having yeah, you should set password aging. That setting password aging is a standard for STIGs for sure. If you guys ever need to see the STIGs, are you guys okay with me making it really bright on the screen for a second here? I'll make it really bright on the screen for 1 second if you guys want. But I'll show you guys like how you do your STIG stuff. Where's my... Hold on here. It's under downloads. STIG viewer. It's gonna get brighter than this. Hold on, guys. This is not the sun yet. Nope, it's not the sun yet. Now it's the sun. Close your eyes. Hold on. Oh God, it came on the other window. Oh gosh. Hold on. Well, that's probably better because now we can see. Okay, so this is a STIG viewer. You can download this from DISA STIGs, right? And if you were like, hey, Scott, yeah, I know, it's a little bright. Hold on. And we go to Red Hat 9, and let's just generate a checklist real quick. We're just going to make one. We're not actually getting... Hold on. And then we'll go down here to filter, and we're going to filter for just password. And here are the password type requirement things, right? And actually, I might be able to remove the filters. Let's do pass WD. This one may be even shorter. But it'll give me where Etsy pass WD is there. But really what I want to do is find if there is a requirement here. I have to go back to password. Hold on. Remove all filters, password. And let me see. I might be able to get away with requirements. I'm just going to type it. I'm going to do just rec. Okay. Let's see if we can find the password requirements section here. Okay. 60-day maximum password. All right. So if you're keeping track here, 60-day maximum password. Lifetime. Incorrect login attempts for 15 minutes. Don't worry about that. The quality. This one is super. Oh god, I hate this one. This one's super annoying. Value of retry. Okay. So that one is just required quality. That's not the one yet. Hold on. That's not it. That's just locking you out if you're guessing. There needs to be a complexity rule. Hold on, I gotta go snooze my alarm for 45 more minutes. And we're gonna have some password complexity rules. Let's go look at what those rules are here. That's a hashing rule. We just still have the one. Here we go. At least one lowercase. So it had to be. It has to exist. It has to be lowercase. Has to have at least one. Decredit is the numeric character, so you gotta have a numeric character. It has to be. You can't change it within a day. There's a reason for that. If you're being compromised, they're gonna try to change your password, but they can't if they force you to change it. Minimum 15 characters, and then watch. This is the one. Hold on. This is the 15 character one. This is probably the most annoying one. Okay, that's a special character. Hold on. So that's 5. Dictionary words. That's 6, right? So we'll go to 6 like that. I will go to 6 like this. And then ucredit is uppercase, so that's 7. And then can't be 8 characters, so that's okay. And then this is the one that bugs me so much. This one bugs me to the absolute fucking nth degree. This one will bother you when you find out about it. It is called character class, and you may not have more than 3 of the same character class. So some of you guys that like to say the lazy dog jumped over the fox or something, and you like to do like capital THE, lazy, capital LAZY, dog, capital DOG or something, jumped, and it's capital JUMP. Nope, can't do it. UMP is all lowercase. Can't fucking get out of here. Can't do it. God, it's annoying. This is the most annoying standard you will ever run into. Or you like to do some caps and nope. Throw it away. I hate it. But I actually have a way of getting around it. But I'm saying like not getting around it, but I'm saying like a different way. Oh, this one is the most annoying one. Oh, the tool. Yeah, somebody wanted to know the tool. This is called the DISA Stig Viewer, and if you want it, they're free. They're free, right? They're just like ducks at the park. You can just go take one. You come here and you say Stig, right? And you go to this download right here. I'm gonna link it to you guys. Hold on. Here's the yeah, the best password is the one that you have to write down. Crash Systems. Remind me. Give me a second. And I'll tell you guys a story about that real quick. This is where you can go find the DISA Stig stuff, and then you just do Viewer. So here's the Stig Viewer, and they're up to Stig Viewer 3. So you can get, and there's one for Linux, one for Windows. I don't think there's one for Mac though, so you can't do that. Yeah, ducks in the park are free. I don't know if you guys knew that. If you just go take a duck from the park, nobody will stop you. They don't belong to anybody. I told my wife that, and she's like, "You better not come home with a duck." And I'll be like, "You're right, but I didn't steal it. If I come home with a duck, I didn't steal it," because we have 2 ponds like that way from my house. There's 2. We have like 2 like nice little like pond parks. It's actually nice. Like as the sun's setting in Phoenix and it's still kind of hot in the summer, when you walk by the park, the water like just cools off all the area around. It's actually kind of a really nice effect. But anyways, that's where you go grab your Stig viewers if you need them. Then you've got to load them with Stigs though. Like, did you guys see how I had my layer 2 and my router Stigs and then my Red Hat Stigs and my MariaDB? I don't have time to go over it now, but if somebody were to say, Scott, I want to know more about that, That will help people who don't know anything else. Sure, sure, sure. Hold on, let me show you guys this. If you want to do some Stig stuff, and you're like, yeah, Scott said he didn't have time to help me, and he left me, out in the cold on a Tuesday or whatever. I'll show you guys where to go get started with Stigs. That's the number one place right there. But they've got a tool on there that you can download and run against Linux boxes and other things. And if you want to test that, here is, I've got 2 labs down here. One is reporting of a server, and one is reporting of like a Firefox with the Stig tool that they have. So I'll link that to you guys. Those are free labs out in Killer Coda. You guys can go do them. Feel free to ask me questions down in the Discord about those if you do them. We're not going to spend a lot of time. We're not going to spend any time on them right now. But since we're trying to do more Linux, I wanted to get us back to the basics today and really get into the Linux stuff. There's that. But by the way, some of this may be enforcing Stig standards for passwords, and that's enforcement is in PAM, which is your Etsy pam.d, right? That's your pluggable authentication modules. And typically we'll enforce L character. So L char equals at least 1. U char equals 1. Digits equals 1. And then special char equals 1. You have to have at least that. And then non-repeating 3, right? That's like a bare minimum. And then 15 char min. Minimum. Those are like hard set standards. Does anybody know? So if I do all that, and then I come down here and I say, this is for entropy, and I say 72 raised 16. Does anybody know what I mean by that? Password gen is great for yeah, you can use a tool for that. I have an algorithm that I use to generate passwords that I can teach to anybody, like anybody that I work with, and there's that. All right. So real quick, let's do some quick. Yeah. Does everybody know what entropy means? Entropy means the passage of time. This thing, all things, devours birds, beasts, trees, flowers, gnaws iron, grinds, gnaws iron, chews on steel, grinds hard stones to meal, ruins kings, burns beats high mountains down, something like that. Does anybody remember that? This thing, all things, devours birds, beasts, trees, flowers. It's time, right? Yeah, Gollum, right, with the time. Well, where I'm going with that is 72 is your base number. Well, what do I mean by that? Well, let's count them up real quick. What's 26? How many lowercase characters are there? 26. How many uppercase characters are there? 26. What does that take us to? 52, right? 52 plus 10 is 62, because that's all your digits. And then all your special characters is another 10 across the top, and that is going to be another 10, so that's 72, right? So you got 72 in your base times 16 places. You've got a minimum of 16 places. Well, it's 15 places, I guess. Right? We could do 15. Now, you can go drop that in Google and see how big that number is, and that's how long it would take somebody to guess all your character combinations. That's assuming they had your hash and your salt. They have to have your hash and your salt for that to work. You keep forgetting your password. Entity of English is 4.2 and not 26. That's fun. Entropy. Oh, yeah. Entropy, yeah. Yeah, for sure. All right, so let's keep going down here. Now, they want you to be able to do security. So, they want you to secure the system in some way. How do we secure Linux? Well, I've got these other notes on kind of a course idea for securing Linux, but it's that benchmark standards. We want to secure the network. We want to secure user access, let users in, let users have access to certain things. We want to jail users and shuffle them off to the ways they should go. We want to do updating of the system. We want to be able to monitor and parse our logs. We want to be able to do monitoring and alerting. We want to do configuration drift and keeping things from changing. And then we want like certificate and best practices around keys and stuff, right? So this is a course that I'm going to be putting together for our guys down in the Discord. But so security management is keep the system safe, right? Keep the system safe. Keep it confidential. What is the CIA of security? Keep it integral. Keep the integrity. And then, and what's the last one? Keep it available. Right? Those are the three parts of cybersecurity, the CIA, right? And integrity is both malicious and accidental or entropic. So what do I mean by that? I tell people all the time, if I lose all your data, does it matter if I intentionally deleted it or if I accidentally deleted it? If I'm your admin at the company and somebody at the company goes to reach for the data and their server or their process or their user or whoever can't get it, does it matter if I deleted it on purpose or accidentally? Does it matter to you if I did it in a fit of rage or if I did it because I just backed over it and ran over the server in the data center? It doesn't matter to you. That's why I often ask you guys, like we'll talk about it when we're talking about security incidents. If a security incident affects confidentiality, integrity, or availability of the system, does it matter that it was on purpose? No, the way you respond to it may, like if it happened on purpose, if something was confidentiality leaked, you may have to go to the press faster, or you may have to whatever, like that kind of stuff. But yeah, I was gonna say, only legally, only in your response does it change. Yeah, only in maybe what we call, but I mean for people that are running that kind of stuff, like your chief information security officer of your company, he should add safeguards in place to keep me from being in there with my little scooter running stuff over. Why was I racing my scooter around the data center to crash into stuff? And then I cracked my head open and sued him anyways because I didn't have my helmet on. And you're like, oh, this fucking guy. Why did we let this guy in our data center? Yeah, it doesn't matter in the sense. Yeah, you got to fix it either way, right? So security management always deals with keeping the system safe. I tell you guys, as when you're going for systems admin roles, the number one key performance indicator, the KPI of any operational system team, is uptime of the system. It's not, it's not any hot button issue of the day. It's not however, represented people are. It is the uptime of that system 100%. That is the only thing that is going to keep your jobs at the end of the year or lose your jobs at the end of the year, is if the systems are up or not. So teach new EMTs, first you stop the bleeding, then everything. Yeah, crash systems. We used to do, so I did a thing called Combat Lifesaver in the Army because I was an infantry guy. And really, it's like, well, mostly I just want to make all the blood leak out of that other guy. And they're like, nah, you got to keep the blood from leaking out of your buddy. So you're like, all right. So we'll just tourniquet everything and tell them to lay there and ice it and put some Motrin on it. Motrin and water, and change your socks. Those are the things that we would tell people. But yeah, I used to have to do that same thing for that. And my wife doesn't understand why I thought it was so funny. Like I'd explained to her, like we'd do these combat lifesaver courses, and then me and my buddies we'd just blow each other's veins up with we'd have to give each other IVs, and we'd just blow each other's veins up, and there'd be blood all over us. Yeah, I was in Iraq. I was in Iraq in 2003, Master my fate. Yep. I was an infantry guy over there, running around with my rifle. Documentation. Big. Because they say down here training people, and I would argue, if you don't do 6, you can't do 8. You wouldn't be able to do 8 because if you're not going to document stuff, you're not going to be able to hand it off anywhere. No, never. All right, hold on, I need some water. So, and the security management stuff, I guess I could bring this stuff over if you guys wanted, but mainly I would say on a server of any type, you need to know what's running on the system, right? You need to know who's running stuff, how it's running. The thing that I would check if I were to go to a server that I've never been on before, SS-NTULP, and I would look for how the system is listening how is this system listening, and what is going on this system? And it looks like I've got some Zabbix agent running on this server. I don't know what people were doing. Somebody was obviously setting Zabbix up, which is fine, right, guys? This is a home lab environment. People can do whatever they want. But somebody has started Zabbix on Rocky 9, which is fine. You know, it's been up for 5 days, so somebody has been on it and they've been working with it, and I think that's awesome. Anytime you see somebody jumping off of this box, that means that they've been coming in. So on the 16th, 5 days ago, somebody was on this server adding Zabbix. Good. I hope they got the process and documented, and hopefully they turned that into like a cool thing for their Linux project, right? But the point is, I can see on this box, if I knew nothing else about this box, it's running some RPC stuff, whatever 111 is, right? I can go look up what 111 is. I got port 22, which I happen to know is SSH, but if I didn't, I can go look that up. I now see that Zabbix is 10,050. It's more RPC bind for system D, and then 9090 is my Promtail. So if somebody said to me, "Hey Scott, is this system locked down in adherence with our company policy?" Then I would say this. This is probably what our company policy is. I'm just going to make this up on the fly here for a second. But our servers can listen to anybody for port 22 SSH. Is that true? Yes, they're listening to anybody on IPv4 and anybody on IPv6. Okay. We can listen to anybody on port 1111. We're going to look that up real quick. 1111 is Sun RPC, so it's just a port mapper. Okay, so that's acceptable. And then it happens to be this Zabbix as well. And I would say, well, Zabbix isn't part of our normal use case of server, so no, now it's out of policy. But I come to find out that it's a dev team that has specifically requested to have a couple dev boxes. This is down our dev environment, so maybe we're a little more loose with this. And we knew that they were going to set up Zabbix agent on them, and I would go, yeah, that looks like it's within the standard. And then, excuse me. So if I knew that was the standard, that we only had 111 open, 22, and 9080 for Promtail Linux. If I knew those were the things that were up. Hey, thanks for the follow. New World Andy, hopefully this stuff's useful to you. Also, I missed a few Black Ops, MP Herring, Adam 69. Hopefully this stuff's useful to you. If we look at this and we go, okay, now I could quickly take this and build a little audit program where I just grep-v those out, maybe. Like maybe I do my SSNTULP and then I grep-v VE for 1111 and 22 and 9080. Was there another one? And now I would be left with, across all my systems in my company, maybe I do these audits daily and I'm just looking for servers that pop up that have bullshit in them. And those two are bullshit unless I know that they should be there, and then I do that. This kind of stuff, guys, is like super easy with just really... You didn't see me do anything magical. I did really simple Linux stuff there. I added a grep to the end of a net, and then if I wanted to do that everywhere, watch, I would just grab it like this. So if we want to see all the non-standard stuff in my environment, we'd come here, Control-C, clear, Control-Shift-R, Ansible, and we would just change this right here to that command. Now Ansible from this box can hit all 19 of our servers real quick. And hold on, that's my bad. you guys gotta stop me sometimes. There, can't use the same characters inside the command as outside. This will work. All right, so this is gonna go and it's gonna hit them all. Crash said on the hardware side, it's not too uncommon to issue where a server may have uptime 5 years, get powered on, and then not be able powered off and not be able powered on. Yeah, I would agree with that. Look at this. A bunch of these boxes didn't have anything going on, except for that one. Looks like Rocky 2, people have added some slap D on there maybe. And then it looks like somebody had installed Nginx. Guys, that's perfectly fine. This is what the lab's for. Somebody installed Nginx on Rocky 5. Perfect. Might have even been us the other day. It's on port 80. All right. And then this Zabbix agent. And very quickly, I could see all the things that are maybe outside of what my normal system, what I might have expected. By the way, I might also find out that Promtail Linux has a separate port that gets listened to on certain boxes, and that's fine with me as well. I could just grep out Promtail if I wanted to get rid of that, right? So, looking at all this stuff, and I made the screen bigger so we could see that. Looking at all that, we can very quickly see, you know, what is running, what should be running. Do we have a risk management profile? Do we need to make one? Like, do we just run Linux systems in our environment and pow, 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 it's just the Wild West and we fucking fire guns off in the air and do whatever we want? Or do we turn this into like an engineering thing where we can actually control all of our systems in an engineering way and start to really manage our systems like you know, like I always say, like pull up our big boy pants, and we're not just doing bullshit in a network. We're now engineering, I hate to say like engineering success, but we're engineering our systems to have the best chance of going as far as they should. So system D is the devil. Yeah, fair enough. Yeah. Documenting system configuration. Just how was it built? Is it built via an automated process? Can we track for drift? Can we track for changes in a system? And why do we want to track for changes? It's not because I'm a jerk and I want to come in every morning and go, something's changed in this environment, and when I find out who did it, I'm gonna kick their ass. No, that's not why we do it. Like, we do it because if people are just changing stuff, we need to have it documented. It needs to be down in like a ServiceNow or some kind of change management request for what's kind of going on with the system. I'm a big fan of building all my servers out the exact same way. Some of you guys have seen, like, we've got Rocky 5, right? That's one of our boxes. Come out, go in Rocky 11. It's different. Why is it different? Well, node list dash A, because they're using, oh, well, that's stupid. Right? Here's all my containers, and some of these nodes are on other containers for some reasons. So Rocky 11 through 16, we can put them on the other containers, reboot them, and get everything back on the same system. Yeah, and it's that idea that, as Local Ken said, it's testable. We can verify that things are the way that we want them to be. It starts to get into some of that project management and like process engineering stuff, but it's useful. All right, troubleshoot anomalies. So have a troubleshooting process. I don't think you have to be an expert in all types of troubleshooting, but you need to know the troubleshooting process. All right, the thing I'm going to show you here real quick is up in the Discord. Let me go here, Linux group, our Linux systems admin course, and I want to say 15 where we did this. Yeah, troubleshooting. All right, here is our, by the way, I tell you guys all the time, I don't care if you know who I am. I'm a real person. You can look me up if you want, or as one of my buddies likes to tell people online, check my references, right? Is this it? Yeah. So we're going to talk about some troubleshooting stuff real quick. And this comes from, there's a version of this up in the Discord. So if anybody needs this, this is under presentations. You just got to go up a little bit. And it's in, there's all these different PDFs up here. Twitch excelling. I think I've got some good ones up there, but troubleshooting is, it's in here somewhere. You just got to find it. There, no, that's template for subnetting. troubleshooting right there. It's the very first one. Yeah. There's a good amount of swearing done in data centers, that's for sure. Especially if you're moving stuff in the racks. All right, troubleshooting concepts. All troubleshooting boils down to the scientific method. Everything we do as admins and engineers actually boils down to the scientific method. I've argued with people for a long time that, like, while I find science pretty cool and I find theoretical science pretty cool, I like engineering because we put science into practice every day. We don't pretend, like, there's nothing that I do that I don't know works because I actually have the output of it to prove that it works, if that makes sense. Actually, Ekaminha, you probably don't know this, but I'm my own bodyguard. I think most of the guys would tell you here that I actually would. I actually welcome. I welcome the attacks. I tell people whenever, at all times. It's one of the benefits of having PTSD from the war is I have never once relaxed in the last 22 years now. So I don't relax anymore. I never have. But I'm my own bodyguard, so that's kind of funny. Anyways, all right, back serious stuff. Scientific method. We observe something, we form a hypothesis, we experiment or test that hypothesis, we come to a conclusion, and then we iterate if the problem hasn't been solved. This model right here is going to be the true way that you do any type of troubleshooting. But let's dig in. Here's some practical tips. Make sure your documentation's good. I like to keep timestamped documentation of things that are happening as I troubleshoot, when something was observed and by whom. And you say, Scott, wait, so as you go through a system, you just mark down everything? No. I mark down things that were anomalous from what I expected. So I go to a server and I do an uptime, and I think that server should have been up for 3 weeks because that was our last patching cycle that took it down. And I find that the server's only been up for 15 minutes. I note that. I found the server at this time to have only been up for 15 minutes. That's a problem to me because now anything that people didn't commit that they have built on that server, especially in dev environments, is now going to be busted in some way, right? All right, or could be busted in some way. Teamwork. Make sure who you're talking to and how you're sending information up. You need to know your tools. I tell you guys this all the time. You can't be trying to figure out how to use TCP dump in the middle of the night when you got called out at 2 a.m. You've got to have used TCP dump and know how to use that tool. You've got to, if you're gonna use NS, so you don't need to know all the servers in your environment. I mean, I get called out. I don't get called out as much anymore in my career, but when I was younger, I'd get called out for servers I had never been on, and the engineer's out of town, so there's no calling him. So I don't know the server, but I know how to do an NS lookup, right? I know how to do this. I'm on my server. I can do from this box. Can I get NS lookup out to Google? Can I get there? Okay, so I've got DNS working. And DNS isn't working the way I expect. Well, in this case, when I cat etcresolve.conf, my system is looking at 8.8.8.8. Does anybody know, and I talked about this the other day, so some of you guys that were around may know what I'm asking here. But if I'm not resolving something internally, right, I'm trying to resolve, and I see this, does anybody know what I'm probably thinking immediately? Like what am I personally thinking? Well, one, I'm always going to compare it to something else, but I definitely see a problem right here. What is this address right here to? Does anybody know? What's 8.8.8.8? Some of you guys have been around the nerd sphere long enough to know. That is a very common Google DNS. Very common Google DNS, right? Do they know anything about Scott's internal? Well, they probably do. But are they allowed to pretend like they know anything about Scott's internal network? No. They're not going to know my internal stuff. Yeah. So, yeah, crash the system. That's pretty good. Although you won't hear it because you're on ads right now. Sorry, guys. Sometimes you get ads, right? That's the old Twitch for you. I get to talk to you guys for free. You guys get to mostly listen to me for free, but you got to listen to some ads every now and then. Hopefully it's not about I used to get the weirdest ads on Twitch. I pay for I pay for like the little turbo because I just hate getting ads. But man, I used to get ads that were, man, I don't even want to talk about them. They're really awkward ads that they would send me. Um, but anyways, I'll tell you guys if you want. But they were awkward, like super awkward. Like I thought they were really weird. 8.8.8, yeah, it's outside of our system. So anyway, so I can look at these things and I can see that things are or aren't the way that I kind of expected them to. Understanding data. How are we going to look at data? And is it continuous or discrete data? Are the data between like 0 and 100% and they're kind of constantly going like this? Or are they ordinal data where something should be happening before something else? Continuous is like, time of day is measured in hours and temperature is measured in degrees, but there's different types of degrees, so we might need to know that. Let me show you guys in the home lab here as we're talking about this. This doesn't have to be all abstract. This is like the home lab environment here, and this is the last 7 days. The number of users on my system, all my CPUs spiking throughout the night. Every night at about 4 a.m., all my systems spike until about 10 a.m. for one box, but other nodes finish earlier. And do I understand why my CPU and memory spikes every day? Do I care? How's my root usage on my servers that I care about? And how's my network storage doing? Is my network storage a little too high? Do I need to go add some more disks to that? ISOs doesn't add very often unless I'm adding new stuff in there. But this is continuous. So look, I have all of these set to a percentage of what I call utilization. Utilization is always 0 to 100%. No crash systems. This is a dashboard that I built in Grafana to view my home lab stuff. Here's my security and connectivity stuff. So here's all the people that have been kicked out of my system forever, and here's the total banned IPs in my environment for the last 90 days. We're up to like 48,000 that have banned themselves out forever. Grafana. So here's the architecture. If you missed it earlier. Oh man, Ekamina, thanks for the gifted. I appreciate that. I think that 5 people will definitely appreciate that they don't get any more ads. I definitely appreciate that because it keeps me motivated. I think it helps keep everybody motivated. But that's I do appreciate that. So check this out real quick. This is the structure. You probably weren't here earlier when I was showing it. This is my monitoring architecture for my home lab right here. This is ingest, storage, and presentation layers. Grafana does all of my presentation. My persistent storage layers are InfluxDB, Loki, and Prometheus. And then ingest comes off of any server. This is Joe anybody, any server in my environment. Telegraph pushes to InfluxDB2. Promtail agent pushes over to Loki, and Prometheus scrapes node exporter. Crash systems. If you need any help with that, we have some pretty good examples in the home lab, and we have some stuff down in the Discord that shows you how to do it. If you need crash systems, if you need to do, like, let's say you're like, hey Scott, I need help building it. I want to practice building it for the first time. This is what I would do. Watch this. Go here to Killer Coda, free website on the web. Free website. I built a whole bunch of labs, and I'm going to send you to the first one that does that stuff. So let's say you wanted to build. Let me just show you real quick here. Grafana monitoring with logs and So if you want to do the log monitoring stuff, here you go. Boom. Colchis, I can show you what it can collect. Hold on. It can collect a lot of other stuff. Check this out real quick. So here's the home lab. Here's the lab. Here's how you would install Grafana. It walks you through installing Grafana. And then once you've gotten Grafana working in the lab, watch this. If you guys have never seen this before, I'll show you this. I think this is cool. I think this is the stuff that, like, rubber meets the road engineering stuff right here. And building out these environments real quick. And then I'll come back to your question, Colchis, and I'll show you that last part. Hold on. So this is going to go. Takes a little while. Let's get the key. Install that. Boom. Download Grafana. Get Grafana running in our environment. Takes a little bit. Takes longer than I can talk about it. I guess I could keep talking about it. But hold on. It's going. Get our daemons to reload here. All right. It's coming up. And you can read what these things are doing. I still need to take that sudo stuff off. There's no reason for sudo to be there. Come on. All right. It's doing a daemon reload and starting it, and that's fine. I just like to restart it just to make sure. Come on. All right, and then we wait for a second, and the system is not quite up yet. It takes about 10 seconds for Grafana to be listening. About 10 seconds or so. Is it flat file config or DB or SQLite? Grafana can be done with... you can actually do JSON configs drop in, and Kolkus, I think, was actually one of the ones who had a really good little deploy of that in our Discord. I think he put it up there for everybody for his project. Hold on real quick. Taking its time. Oh, let's start it. I don't know why I didn't have it started. Now it's going to take about 10 seconds. We'll see it there, but it's not quite listening yet. You guys see it's not quite listening yet. Give it about 10 seconds. Now it's listening. Now I can hit that button, which will be unique to each lab, and it'll just be the new instance of... it's in the Ansible code channel. Nice, Kolkus. Yeah, and then now here I could just log in as admin, and then I can change it to... I'm going to change it to 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8, and then I would build all the pieces of the lab environment out. Never. And then now I've got Grafana, and I can go install everything. All right. The reason I showed you guys that was that's kind of the way that all works. So, all right. So we got to understand our data, and accuracy of how you collect your data, tremendously important. Let me show the telegraph part real quick because there was a question. So in my home lab, telegraph. All right, so Kolkus, this is to answer your question. I will show you all the stuff that Telegraph can collect outside of just node exporter. So actually, you know what? This isn't the best way to show you. Well, I'll show you here first, and then we'll look at the other one. So here's the telegraph.conf. And there's 3 things that are happening. Well, there's 4 things, actually. It's input, process, aggregation, and output. Those are the 4 things. But process and aggregation are really just process, let's say. And let's look real quick at this, where here's some global tags. If you had some global tag stuff, here's some agent stuff that you can just change the way that the agent works. But now I'm going to start going page by page, and here's the output plugins. We could go to InfluxDB as I am, or, and there's a whole bunch of stuff for it, we can also go to an Ammon server and AMP Q broker, whatever those are. Those are some different types of stuff. We can send stuff to Azure Monitor. We can send stuff to Telegraph to Google Cloud PubSub if we had topics in PubSub. If we had CloudWatch, we could send stuff up there. We could send stuff to Datadog, to Discard, to Dynatrace, Elasticsearch if we had it. XD, we could send it to a different Telegraph metrics file. Graphite, if you're using Graphite. Graylog. Okay, so you probably see that there's a lot of things there, but hold on, let me pull this up real quick. So we come over here, and we look up InfluxDB, Telegraph. Telegraph agent outputs, right? And it'll take us to here, and then this is the page that I like to show people. Is this the page? Hold on. Where we can go to data collection. I think it's under integrations. Sorry. Yeah. Here's the thing. So here's all the places that That's not what I want. The point is, Telegraph is super useful for sending and receiving to all kinds of different. Here's the collectors that it can come from. So it can go gather data from things, and it can also send data to things. In my home lab, though, the question was, what am I doing in my home lab with it? I actually have external queries here go out to weather.data. the hell is that? It's a weather site. And then also I have some data collection stuff that I was doing from Telegraph out of what's the internal data collection one? I don't remember where this was going. But my external queries was I was gathering weather data. Oh, Colchis. It is much more than just like Node Exporter squeezes up everything out of your system like it's squeezing a little tube of toothpaste, and then Prometheus comes along and scrapes it, and that's pretty good. But Telegraph can gather, it can batch stuff up and wait. Like if the influx DB's down, it can wait for up to like an hour to send data over to it. It's really good. Like Telegraph is it's got like a robust connection. It knows what it's put over there. It's a lot smarter than just some Beats agent or like a node exporter. So Telegraph can do some pretty interesting stuff, but it is a little heavier weight than these two. So, but it's still not too bad. Anyway, so hopefully that answers that question. All right, let's go back over here. Yeah, what's that weather? What's grep? Yeah, so it's the open weather map. Yeah, and then we can grab weather stuff and send it over. And then you have to have an API, which I have an API, but is it open weather map or one of the other ones that does it? Anyways, the point is I have an API key in there that I use, but you'd have to get your own. You shouldn't show your API key on stream, right? That kind of stuff. But that's one of the inputs that I use to go gather all my weather data. And then I used to have a weather page that I'd show you guys often about like how hot it was in Phoenix and Manassas. And the reason I compared Phoenix to Manassas is those were where the two data centers are for the NOAA that I worked for. I worked for NOAA. Well, that's one of the places I work for as kind of a sub to my main company. All right, so administrative troubleshooting. How do we troubleshoot, right? There are some 8-dimension problem-solving techniques. So look at this. Establish a team, describe problem, develop interim containment actions. I don't want you guys to memorize these. You can just look at them real quick. And then I'm going to show you from this 8, what do you guys think I'm going to show you next? That's a pretty good one, Crash. Yeah, if you want to see my API key, you have to buy me dinner first. Or the most famous one, which is, I'm not an idiot. You got to show me the candy before I'm getting in that van. All right, I'm not a dummy. You just got to show me the candy first. All right, 8-dimension problem solving. And then 7 steps of troubleshooting. Doesn't that kind of sound like, well, isn't that the same thing, just shorter? Yeah, it's like 8-minute abs. And he's like, isn't it only a short amount of time until somebody comes along and does like 7-minute abs? And he's like, not 7-minute abs. You can't even get your heart rate up, or whatever it is. I don't remember. I don't know if any of you guys remember that. That's from an old movie called what is that one? Oh god, that movie's like 20-something years old now, probably almost 30. Ben Stiller and Cameron Diaz. What's that movie called? Where the guy's homeless and he's killing everybody, and everybody falls in love with that girl. I literally can't think of anything. Yeah, something about Mary. That's exactly right. I was thinking of all the scenes that I could say from the movie, and then I was like, I can't think of anything from that movie that's not too dirty to say on stream. That movie was tremendously dirty from start to finish, but it was pretty funny. All right, anyway, so troubleshooting. Again, 7-step troubleshooting. 6 steps of troubleshooting. This is the one, somewhere between the 6 and the 7-step one is the one I learned in the military. But look, this is identify a problem, establish a theory of probable cause, test your theories, establish a plan of action, verify that it fixed it, or come back up to the next one, and then when you're all done, document your findings. This is the way we do things, guys. Troubleshoot. And I don't want you to memorize all of these. I want you to find 1 or 2 that resonate with you, right? These problems, troubleshooting, they will always work for you if you're capable of, determining all the theories and then testing through them. You'll eventually find the right one. If there are unknown things happening, then sometimes you got to kick it off to somebody with either deeper knowledge or deeper access of the systems, that kind of stuff, right? This one is, I actually really like this one. This one did come from Microsoft. This is a Microsoft model. But I've always thought that this one worked well for people. Like, I think especially like junior, when you're first getting into systems. The first three are how we get the system back running. So it's real easy. Research, engage, adjust. Then the last two are configure and take note. So research, engage, adjust gets you back working. And then the CT of your React are to configure and take note how to keep this from happening again, right? That's what's commonly called the React methodology of troubleshooting. These are admin troubleshooting techniques that we're doing. We're going to do engineering ones next after this. One of my favorites, stepping through the OSI model. So the OSI model, right? Application, presentation, session. You should know that probably at a high level. You don't have to be an expert in it unless you're a network engineer, right? But then if something's pingable, so if I can ping it, that's right here because that's where IP addresses and ICMP live. And if I can ping it here, I do not need to go over here and make sure that the box is turned on and that the cable's plugged in and that the NIC is configured and that it's on the wireless. I don't need to do those things because I can ping it, right? Similarly, if I can get to a box and then I can ping Google, I'm able to get all the way up through the application layer for DNS and come back, and then I'm able to ping Google via IP and come back. So I have a pretty good amount of system. You know, if I'm looking at a system like this, and there's a lot of stuff that I know has happened right there. There's a lot of stuff that, you know, just happened in my system. If I don't have Google in my host file, which I know I don't, then that means that a lot of stuff just happened for that to work. The security onion approach. Please do not take salespeople advice. I like it. I actually hear new ones. Like I've been teaching for 16 years, specifically networking, at the college level, and I constantly think I'm never going to hear a new one, and then some student will surprise me with a new one. I should just start keeping track of them all. I'll start doing that this next quarter, and I'll just start keeping track of all of them. And then if anybody ever says, "Hey, do you know all of them?" and I'll be like, "I know a lot of them. I know all the dirty ones too," because the college students don't mind telling me the dirty ones. So there we go. All right, but we can see what's going on here, right? And then we've come in here, and I've shown you guys you have a lot of power on your tool. We do this when we do the Socratic method. We say, okay, we can ping Google, right? And we're going to ping -C1. And it says that I pinged it. And I know that the way that I got to that system was if I was pinging 142.250, it doesn't match this, so it doesn't go out this interface for this route. But the default is here, and it did go out that interface because it was default. There was nowhere for it to match, right? Like, we know that. We can troubleshoot that if we have a lot of routing options. We can troubleshoot how our system is going to send something out. But it sent it out, and it's working, and we know that's good. But then if we look at our device and we see that the Ethernet has a maximum transmission unit of 1500. I've shown you guys this before, where we can break that packet up, or we can not break that packet up. We can give it a size of 1500, right? And that actually can't use Google anymore. Google, they won't respond to bullshit. Google, once you start messing with stuff, they go, nah, we're not listening anymore. And we sent over a packet that was 1500 bytes, but it was 1528 bytes, so it was bigger than the frame could accept. So they had to split it into 2 frames to get it across the network. And you might say to me, well, Scott, can you prove that? I say, yeah, we can prove it. Uh-oh. Well, I have to look at something here real quick for work. But I come over here and I say, okay, yeah, I can prove that. I can say -M, do. And now it'll say, nope, can't send it. Can't break it up. You said do set the don't fragment bit. And when I did set the don't fragment bit, that's what that means. The message was too long. So without it, it works fine. With it, can't work. But I could send a smaller one. That'll fit real fine as we go down into the data link layer where the Ethernet 2 frame sits, right? The packet coming down is too big to fit and it can't be chopped up. And the reason I show you guys that is because, well, since I'm a networking guy, I gotta show that stuff to people. But that's very important for if you expect like maximum transmission units between, you expect what are called jumbo frames on the line so that you can talk to like storage or something, and you can talk to your storage device just fine, but then you go over 1500 in your pings and it no longer gets from your side to the other side. And then you call up your networking guys and you're like, hey, you guys told me that connection was set the whole way, and they're like, yeah, it is. And then you go, no, I can't get over there. And then, oh shoot, that one link, and then they fix it and everything works. And you're like, right? And it's not, again, I tell you guys all the time, being an engineer it can be combative, but it doesn't have to be combative. We just deal with what's true. That's all we have to do. We prove something's accurate. We show what we mean to say by documenting our things, and then other people have to go, no, you're right. I'll go check on my stuff. Oh, there it is. And then they find it, and then everything, all the data are flowing exactly like they're expected to, and then everything's good. So stepping through the OSI model, tremendously important, tremendously valuable. We do that in some of our Linux systems administration course stuff. All right. You got to know how things flow, right? This is an important diagram to understand, right? This one right here, this is how doctors diagnose you and other people that have problems. This requires you to be an expert in systems, but not that system. And you say, what do you mean by that? A doctor knows ears, nose, and throats, maybe. They don't know you at all. They've never looked at your ear, nose, or your throat before. But when they look at your ear, nose, and throat, they can tell what's wrong. And this requires you to be an expert in systems, but not necessarily an expert in the specific systems you're in. You know what the symptoms of a broken Linux box looks like. You go and try to figure things out and test some assumptions, and then you treat it with the best way that you know how to get it working. And that means that this kind of stuff is like anybody can be called in if they're an expert. Contrast that with this one, where you need to be an expert in systems like I just showed, and you need to be an expert in this system. You need to understand that the data request is going to come in. It's going to be HTTPS, meaning that it's going to have a certificate. It's going to expect your load balancer to have a proper termination of that TLS communication and be able to be trusted as having the certificate, right? So it's going to do its TLS little walk between the server and the client to make sure that it is who it is. And then your load balancer sends that data to one of your maybe 10 backends, which are EC2 instances that are running with port 5000 open for your application. So, there's maybe been from that API gateway that then comes back, it's coming on port 5000, and it is sending through the header information that's supposed to, so that then that server knows what to do and cache everything. And you understand that the caches are locally on each of those nodes. It's being sent over maybe to Redis, and then your Redis server is sitting there and holding all of the cached information in case any of your EC2 instances get axed, because maybe you're running spot instances to save money and they can die in 2 minutes at any time. So so something's broken in all that, right? And you understand how the data flow from the beginning of the request all the way back to the database that it lands on, and all the way back through for it to be finished. And now you're sitting there doing systems thinking troubleshooting. So this type of troubleshooting here is you understand how the interdependent pieces are working. You understand how they connect. You know where to go look. Hopefully you have good logging and monitoring set up to be able to do trace data of a flow of data through your system. How are they supposed to communicate and what is not working? And then what other devices are attempting communication at the same time, So maybe you understand that the system's under high load and one of your machines was taking more connections than it should. And after it took that 5,000 and first connection, so it could take 5,000 connections, but when it took that 5,000 and first, it fell over faster than one of those, if you guys remember the Affordable Care Act servers for the U.S. when they first turned it on back in like 2010 or something, that thing went just broke, right? What is changing the environment and within the system operates, and has systems been physically moved or any changes to the environment recently, right? It doesn't have to even be physically, but you have to understand the systems, right? This is all system stuff. This reminded me of a vendor issue I ran into a SIP session border controller. Oh yeah, SIPs. I was having people do some SIP stuff the other day, adding so many of their own internal X headers to the SIP message that they breached the 1500 MTU. Yeah, and weren't fragmenting the packet. I showed them, and their response was, "It's not a problem in our testing." Yeah, if only the internet supported jumbo. Yeah, fair enough. Yeah, crash systems. That's exactly right. Users are going to use, right? Sometimes users are other engineers that just don't understand how their data moves, right, between systems. All right, this is one when you're in the middle of like firefighting actual security incidents. Kepner-Trago is a paid-for methodology that you guys can go get into. Your organization may send you the training, but it's situational analysis, problem analysis, decision analysis, and then potential problem analysis. And they have different ways to walk through these different things. Hey, Master Yak, hopefully this stuff's useful to you. We are not working too hard on a, what is this, Tuesday? Yeah, that sounds right. We're not working too hard. I have college here shortly. I got to teach in a little bit, so we'll do that. And then we'll hop on Fire Exit. Thanks for the follow. So now let's get into engineering trouble. All those things I showed you have very specific. This is administrative troubleshooting. And you're going to say, why do you compare that to engineering troubleshooting? Because an administrator has a very, there's at least one thing that an administrator has as an advantage that an engineer might not have. And does anybody remember what that is? I don't know if anybody here remembers what that is, but of my Linux engineer, my Linux sysadmin people, you guys know that administrators know that it did work at one point, and now it's not. Administrators also can sometimes compare it to other systems that are working to see what's different. Engineers don't always have that. Engineers are sometimes building new stuff and going off into new spaces where theoretical things are coming to fruition or being practiced for the first time, or you're bringing some software into an environment that it hasn't been run on before. We know it works on the architecture and the kernel and maybe the InfiniBand interfaces. We know all those things are good, but nobody's ever spun it up over there and hit the gas on it to see how fast it actually goes, right? So engineering troubleshooting can be different. And that's the main thing I want you guys to think about when we get into this area of troubleshooting. All right. So check this out. Failure modes and effects analysis. I like to show you guys this one. This is a way that systems can be, you can start to troubleshoot before you even ever build something. And as engineers, if you've been around and built things, you will sometimes try to identify problems before they happen. So FMEA is a way to organize and figure out problems even before a system's built, or in a pipeline of system building is how I've used it, and I'm going to show you guys an example. But we identify and list all the possible failure modes that we know of, right? We assess and evaluate the severity, occurrence, and detection of each of them. And then we give it a risk priority number. So there's a thing called an RPN that we're going to calculate. All right. This is how I learned about it. It's a military and government technique from the 1950s, and it is a systematic process to examine what could go wrong, what's the impact, what's the likelihood, and how can we detect and react. So we want to know these things before we even start some operation, right? So this is another thing about it. Make sure you understand your system functions, and you can decompose the system down to whatever part you want to look at for this. I'm going to show you guys from a system build perspective, and this is one that I've actually done at a company right here. So the first one I did was I rounded up all the possible failures. What was happening was, and some of you guys have been around and heard this before, but it's here's all the possible failures for, in our case, it was a server build pipeline. and my Linux engineering team had about 200 dev teams that we supported, and any of those dev teams, excuse me, could come to us and they could push a button. They didn't even have to come to us. They could just push a button, and this little server would come out, and they would pop up with a non-prod server in a non-prod environment. That server would be up for like 2 to 3 months. I think it was 3 months was what we built it for, and then after that, it would automatically just die. When we built that server, it had to be built to a certain security posture in our organization, so we had a golden image, and that image was set in this backline, this back-end storage that all of the ESXi machines could access. But if they couldn't access it, if the image was unavailable, the build of the server would fail, and our way of controlling that and keeping it from happening was monitoring all of our vSphere systems so that that wouldn't happen. Okay. Then another one was we had automation job kickoffs fail. So what would happen is as they pushed that button, they were doing it in VRA, which was some tool from VMware. And then it was going to VRO, which is the vRealize orchestrator from VMware. And that thing would go and log into different systems that we had. One of them that it would kick off would be all of our Ansible tools from Tower, or what became Ansible Automation Platform. And it had system credentials to call Ansible playbooks, and those system credentials had to be renewed like every 90 days in our system. So if they went to do it and it failed, the system credentials would just be out of date. So what we did was we decided every morning at like 4 a.m. before people would come in for the day, we would have a daily build process that would just kick off and build all of our systems. Okay. So it'd build all of our systems, and if that worked, that probably wasn't going to be a problem for that day. So that was our control to keep that from happening. This one was you had your agents that had to register outside of the company. So maybe you had like an Avamar agent, and Avamar was going to back up to some cloud, whatever. And maybe that agent credential had fallen out because we had went to a new version of the agent, or we were pointing at some subfolder in there and nobody had ever given us that information. So we would just verify that with those same daily builds. As if the system built and everything worked, we were good. If it didn't, we had to go figure that out, right? And this was all part of our pipeline, but these were things that could go wrong. And then the last one, this was the most insidious one, final build checks. We don't know what caused it. We just got to the end and we did a bunch of checks and they were busted, and then the server wouldn't be done and we wouldn't send it. We would want to catch this before we sent an email to them that said it was done and then gave them a busted server. So, okay, that's good. I went and rounded up in a qualitative fashion all these things. It's not quantitative yet. There's no numbers yet. But now we're going to take all those things and we're going to assign a severity times a probability times a detection risk. So we're going to get a risk priority number. Now, we're going to do some math real quick here. If you have 1 times 1 times 1, this isn't one of those questions where it's like we're all going to argue about the right answer. There's only going to be one right answer. There's always only one right answer in math, by the way. But anyways, what is 1 times 1 times 1? Does anybody know? Anybody want to try to figure that one out? 1 times 1 times 1. Super easy, right? So what's the lowest risk priority number you could have? 1. Oh, Robodom. Oh, Robodom, I got to take away your mod for that. All right, 1, right? And then what if we had 10 times 10 times 10? What would that number be? That'd be 1,000, right? So your risk priority number is between 1 and 1,000. Always, always. And the number that's highest is the number with the highest risk. It's the thing with the highest risk in your environment. Isn't that simple? It's a simple way to distill this down to what we should be focusing on. And in this case, we had a really bad detect and react with this Avamar register, or agent register rather, to server backend. So that was one that I would want to spend some time with, right? There you go. All right. Another one. There's 3 that kind of help you get to root cause analysis as an engineer. They're called the 5 whys. They're called the fishbone diagram or the Ishikawa, and then the FTA, which is the fault tree analysis. These are 3 ways that engineers find the root cause of problems, right? So ask why 5 times or until the root cause is identified. It's simple but effective. Detractors will say, well, what if you don't get to the root cause by 5 whys? And I say, well, whys are free, so just keep asking why. No. Fishbone is visualize all the potential causes of the problems and by looking at the inputs and then figure out what could be causing the problem, right? Inputs and environment and all these kind of things. So we're going to look at that. And then fault tree analysis is a top-down deductive failure analysis in which an undesired state of system is analyzed using Boolean logic. True, false, yes, no, and or, right? Those kind of things. So here's a 5Y worksheet. And we actually worked on this when I showed this to the group a while back. It's in week 15 of the Linux Systems Admin course for people that want to go watch it. But we walked through the 5 Ys and we said, abnormal condition, my web server won't start. Why did this occur? Well, web server won't start because the systemctl daemon can't start it. And we might say, why is that? Well, it's telling us because the maybe logging is full. So we ask, why is it not starting? And it's because the logging's full. Well, why is the logging full? Well, because there was 10 times as many events last night as normal. And I say, okay, well, was that expected? Yes or no? And then maybe we come down and we say, well, why were there 10 times more events than normal? Well, the load balancer went down, and this server assumed the virtual IP, the VIP, and this server took all the load that normally went to 10 servers. And we say, well, that's a problem. But here's the thing. We had built that in, so we knew that was going to happen, but we did not know that the server wasn't going to be able to handle that load. So then we say, okay, well, why weren't we aware of, or why weren't we prepared for that? Well, we had never seen it before. And then the answer is maybe if we're going to leave this model, which I wouldn't advise leaving that model in the future, but if we were going to leave that model, this server needs to have more capacity and more capabilities or whatever. So that may be a way that you ask whys down a sheet to figure out what's going on in the system, right? And man, I've seen these done many different ways. And again, this is one of these things where whys are free. If you get 4 whys and you get to the answer, you don't have to ask another one. If you get to 5 and you want to ask a 6th why, nobody's going to come in like in a bunch of penguin outfits with little hammers and beat you because you used a 6th why. Nobody, you know what I'm saying? There's no police for that. It's just like the free ducks at the park. Nobody's going to stop you. They're yours. All right. Here's a fishbone diagram. And you do actually draw this out on the board. And you say material, measurement, machine, method, environment, and people. And the wrong part is produced or the wrong size. Well, no, in our environment, it's not that. It's we're not able to produce a working 202 or 200 message out of our Nginx server. Well, and then we come down and we say, well, is the machine busted? Okay, the machine was full on logs, and that caused the partition to fail or whatever. So we'd write that in here. And people, we let the junior engineers build it, and we didn't pay attention to them. Penguin outfits for sure. Measurements. So again, you may find 1 or 2 of these things are empty. But this is still, it would tell us information about the machine and the employees. Some employee made a mistake or whatever to cause our incorrect output of our system. All right. Fault tree analysis, an AND or an OR gate, and a fault event. And in this case, the plant burns down. We had combustibles and a fire out of control. And the ignition was either smoking or sparks or a short. And then we would expect to be able to find what those things were, right? We could try to figure that out. Then from here, like if you want to learn more about this, there's a methodology called the Six Sigma, which is a whole discipline that you can get into if that stuff's fun to you. And it just talks about how to improve processes. It's process improvement in an organization, and companies need it. And Six Sigma, you can get your white, your yellow. Your white belt's free if you want to go take that test. It's super easy. Green belt is white, yellow, green, black, and master black are the belts. And I'm telling you, I've never known a master black belt in Six Sigma that didn't make over $200K a year. Never met one. So I'm not telling you that it's going to do that for you. I'm just going to tell you you would be the first that I'd met that didn't make that. But you need to know some stuff for that to be able to get it. But this is the Plan, Do, Check, Act. That's a methodology of that. Oh, people are doing Six Sigma big time. Yeah, Six Sigma is all kinds of big. Yeah, if you go to like a big engineering company, Six Sigma is huge. So is TQM, Total Quality Management. Yeah. Robodom, the white belt is free, yes. The white belt cert is free, and it only takes probably a couple hours to study. I actually thought about one of these days just doing like a study session and we just go all take it and pass it. I think people should. I think it's just another positive differentiator for you as an engineer if you want to be an engineer. I don't care what type of engineer somebody wants to be. Understanding processes is key. So then this is one that's important, the SIPOC diagrams, suppliers, inputs, process, outputs, and customers to any process. So what's supplied to a process, what are your inputs, your processes, and your outputs, and then who are the customers that benefit from it. And this may seem a little simple, but this is actually something that should be pretty easy for you to fill out along, maybe even like a fishbone diagram. What is happening in your system to figure out like what's breaking. Okay. Then there was some lab task stuff. Okay. Get rid of that. I didn't even mean to go that far into it, but learn how to troubleshoot. And then there's Kepner, Trago. There is Six Sigma. Those are all the things we were talking about. How do we troubleshoot systems? All right. Okay, so I got to get off here soon because my college class is coming up. But training personnel need to have good documentation to train others. If you don't have good documentation, you're not going to be able to pass that information on. You're not going to be able to tell people to read the field manual if they don't have a field manual to read. This last one, that's specific to their company. So I'm going to remove it because it's not really important to this talk. But train users need to have good documentation to train others, need to understand what you do as a process. There's a guy, Edward Demings, who used to say that if you can't describe everything you do as a process, you don't know what you're doing. And that's true. You need to let them know here's where you start, here's where you go, here's where you finish. My problem with Six Sigma is it allows for lowering the bar to meet what you can produce. If you aren't careful, you end up with enshittification. Fair enough. But the most important part to me is bettering the process, right? Understanding your tools you have to measure output at each individual layer. And I will always be a guy who will tell you, you got to know how to use your tools, guys. Using your tools is one of the most important parts of being a sysadmin. Excuse me. This one was interesting. They wanted you to have a security clearance. They wanted you to have a bachelor's degree. And they wanted you to have 8 years of experience, 5 years with Linux. They wanted you to know current Linux Plus or Red Hat or Security Plus certs, so that's good. They wanted you to have configuration management of physical and of virtual. So they wanted you to be able to do these things or have these things. The DoD 8570 IAT Level 2 certification is handled by Security Plus, so you needed to have at least that. If you guys have never seen that, you can just throw that in a Google browser and it'll tell you what certs you need. I don't even look at those because I have a CISSP and a CCSP, so I'm like at the it's like the top of both categories. So, yeah. So, crash systems. We have a lot of stuff in our Discord about taking certs. A bunch of us went and got a whole bunch of AWS certs in the last few years for fun, and that's kind of like a thing that we did. They want you to know these things and be familiar with these things. So you gotta spend some time in here, right? All right. So guys, I do have to get off of here, but actually let me go to my little end of stream thing real quick. You guys can see the follows. Boot Panic, thanks for the follow. Hopefully this stuff's useful to you. I'm gonna keep doing these for a little while because I hadn't been doing these where we were really digging in like this for you guys, and I really want to just start focusing on these again a little bit because I want people to be confident that they can go get a job in this area if they want. Yeah, I appreciate you having around Crash Systems. By the way, you guys are always welcome to hang out down the Discord. That's completely free down there. And you just can go and talk shop with other engineers and hang out and stuff. So it's always welcome. So, yeah. All right. Well, I'm gonna go find somebody to raid on the Twitch side. Let's see if there's anybody doing anything fun that we can go raid over into, and then we will raid them. Let's see who's on. Is my buddy on? No, my buddy's not on. So we will go. We will go raid into El Colon Q or Clonk. And if you guys want to raid over to him, we'll do do all the Linux as our raid message. But I appreciate you guys coming by, and I will see some of you guys probably tomorrow. All right, take care.